Okay, so when finding the interval of convergence for a power series, we're going to use the ratio test. That's in section 5 if you guys haven't made it that far yet either. The ratio test is the limit of the n plus 1 term divided by the nth term in an absolute value. So this is going to come out to be something, and depending on what that something is, it's going to tell us where this thing converges. So we'll just write this out. It's still the limit as n goes to infinity of this absolute value. The n plus 1 term is going to be that negative 1/3 to the n plus 1 times x minus 8 to the n plus 1. Just replacing the n's with n plus 1. Okay, so it's going to be that as the numerator, all divided by negative 1/3 just to the n times x minus 8 to the n. So hopefully this will, yeah, that looks perfect. So like this, just the n plus 1 term divided by the nth term. Okay, there's a lot of different techniques that we can use here to simplify this thing down. The technique that we're going to use for this one is some exponent rules. In the numerator, I have this negative 1/3 to the n plus 1, but I'm going to think about that as just negative 1/3 to the n times a negative 1/3 to the 1, splitting up those exponents into the two separate exponents using the product rule. So I'm just going to write it all out for this time. So let me just copy this down here. So like I said, we're going to rewrite that as negative 1/3 times another negative 1/3, but just to the 1. We're going to do the same thing for this parentheses here. That we're going to think of as x minus 8 to the n times another x minus 8 to the 1. The reason we do that is now I have a negative 1/3 to the n on the numerator and the denominator that cancels, and x minus 8 to the n in the numerator and the denominator that cancels. All I have left is the limit of a negative 1/3 and then an x minus 8. Okay, there's no more n's inside of this, and this limit was as n goes to infinity. So because of that, this is just a constant with respect to n, which means this is going to be the limit. So this is just going to be, the absolute value makes that negative sign disappear, and then it's 1/3 times the absolute value of x minus 8. Since we don't know what the x is equal to, it still could make the inside of this to be negative. We're going to keep the absolute value going. Okay, this number that is the limit of this ratio is what we call rho for the ratio test. If that rho is less than 1, then we have absolute convergence, which is what we want, right? We want our power series to converge. The only time the ratio test gives convergence is when the rho is less than 1. So we will set that value that I have, that 1/3 absolute value x minus 8, we're just going to force that to be less than 1 because we know this is now where the series is going to converge based on the ratio test. All right, at this point you're using some algebra techniques, and I'm sure it's been a little while since you guys have messed around with absolute values and inequalities. We're going to multiply that 3 over. Don't have to worry about flipping the sign when multiplying by a positive number. Then, anytime you have an absolute value is less than something, you're going to squeeze it between the positive and the negative of that something. So absolute value x minus 8 is less than 3. We're going to rewrite as negative 3 less than x minus 8 less than 3. And then we'll just add 8 everywhere. And we get this. 5 is less than x is less than 11. Okay. This is called the interval of convergence. In other words, this series that I started with here, this series will only converge in this interval. What we don't know yet is we don't know if it converges at the end points. We need to try the end points. So let's just try the first one, x equals 5, and see what happens. By trying x equals 5, what I mean by that is let's plug 5 back into the original series and just see what comes out of that. So it's going to be the infinite sum n going from 0 to infinity. We still have that negative 1/3 to the n out in front. Then it's going to be 5 minus 8, which is negative 3 to the n. Because both of these are raised to the n power, you can go ahead and multiply them together on the n side and raise the whole thing to the n. So now it's going to be the infinite sum, n going from 0 to infinity, of just, so negative 1/3 times negative 3 is 1 to the n. But 1 to the n is always just going to be 1. All right, this is 1 plus 1 plus 1 plus 1 plus 1 forever and ever and ever, which definitely diverges. Okay, so we just found that when x is 5, my series diverges, so I'm not going to include the 5. Let's try the next value, x equals 11, and see what happens. So we're going to do the same thing. We're going to plug it back into the original series. Still have that negative 1/3 to the n, but now it's going to be x minus 8, which is 11 minus 8, positive 3 to the n. All right, that simplifies down as well. Excuse me. So still the sum as n goes from 0 to infinity. Negative 1/3 times negative 3 is negative 1, and that's going to be to the n. But this diverges as well. So this is the series that goes plus 1, minus 1, plus 1, minus 1 forever and ever and ever. That's never going to converge to a sum. Okay, both of my endpoints diverge, which means that the series converges only on the inside of that inequality between 5 and 11. We are not going to include the endpoints because we just found that it diverges at both of those endpoints. So we're going to pick option A here because the series is going to converge in a compound inequality. Sometimes it only converges at a single point, and sometimes it converges for all values. But for us, it's going to be in an interval like this. Cool. The next thing it's asking for is, well, what is the sum of the series? The only time they are ever going to ask you to find the actual sum of the series is when you're doing geometric stuff. So that tells me that this original series really is a geometric series, and I can find the sum. So you'll just have to either have the formula in front of you or remember the formula. The formula for the geometric series sum is a over 1 minus r. So if I copy my series down here, I want to rewrite this in that form for the geometric series. The form for the geometric series, if you remember, I'll write it here. There was 2 different ways to write it. Since we're starting at 0, I'll do that one. It's the sum from 0 to infinity of a r to the n. All right. So to rewrite our series a little bit better, we're going to write this as the sum n going from 0 to infinity. My a value out in front is just going to be a 1 since there's no constant anywhere out in front. That's going to be times r to the n. And to get r, we're going to multiply these two things together. So I'm just going to distribute that negative 1/3 into these parentheses here. So it's going to be negative 1/3 x and then plus 8/3 to the n, lowercase n. Oops. Oh gosh, there it is. Okay, so again, what this tells me is that a is just 1, and r is that whole parentheses there, negative 1/3 x plus 8/3. So that we're going to plug into a over 1 minus r, which is going to be kind of complicated looking. 1 over 1 minus negative 1/3 x plus 8/3, like that. So we'll simplify this down a little bit, distributing the negative sign into the parentheses here. We're going to have 1 minus 8/3, which is negative 5/3, and then negative of negative 1/3 is positive 1/3. Another thing you could do here to make this look a little bit better is to multiply top and bottom by 3. I'll go ahead and do that. So we get this, 3 over x minus 5, and that has to be the sum. I'll go back to that screen just a second. I just wanted to get the green check mark. Okay, so for those of you that just finished up the last homework when you're doing geometric series stuff, geometric series will also hold for these power series where you have variables in the series. So just rewrite it in that a and that r to the exponent format and plug it straight into the formula that I hope at this point you guys have pretty much memorized, the a over 1 minus r. Is this okay so far? Is there any questions about anything that we've done on this question? Okay, assuming not. Moving on. So there's a lot more parts. The next part, what series do you get if you differentiate the given series term by term? So for that, let me just write out the series again. So to differentiate term by term, you want to think of the x as being the variable that you're differentiating with respect to, and you just do it normally as if there wasn't a sum out in front. So the derivative of the above statement still is going from n equals 0 to infinity. That negative 1/3 to the n is a constant with respect to x, so I'm just going to leave that alone. But then we have x minus 8 to the n. So it's to the n exponent, which means you're going to have to do a chain rule here. A chain rule derivative is the derivative of the outside, which is bringing the n down, leaving the inside alone, and then taking 1 away from the exponent. Then the derivative of the inside, but the derivative of the inside is just 1. Okay, so then just picking the one over here that matches what I have, we have a negative 1/3 to the n, we have just a normal n out in front, and then it's x minus 8 to the n minus 1. It looks like C for the options that I have here. The n, negative 1/3 to the n, and then x minus 8 to the n minus 1. The point of this question is just that to show you that you can take derivatives of these power series, and it's kind of neat. The next part, for what values of x does the new series converge? So this has to do with a theorem that's in the textbook. Whenever you have a function as a power series and you take the derivative of that power series, the convergence is going to stay pretty close to the same. In fact, it almost 99.999% of the time is going to be the same. So the interval of convergence was between 5 and 11. This one's also going to be between 5 and 11. So don't worry about the times that it's not the same, because that's never going to happen for you guys. When you take the derivative of a power series, just know that the interval is going to stay the exact same as it was for the original power series. The next question, what is the sum of this new series? Remember that the sum of the original series was 3 over x minus 5? And then we just took the derivative of the power series representing 3 over x minus 5. This is going to approach the derivative of the original sum. So we'll just take the derivative of 3 over x minus 5. As a derivative, we're going to have to do, I guess you could do it however you want. You could do a quotient rule here, or you can think of that as being x minus 5 to the negative 1, which is how I'll think about it. So we'll bring down the negative 1, leave the inside alone, take 1 away from negative 1, but then multiplying by the derivative of the inside is just 1, so that's not going to do anything. Bringing that back down to the bottom, it's going to be x minus 5 all squared. Okay, I think it's a really good question. I think it has a lot of the different material that you guys are going to need to know when it comes to the test for Chapter 10 stuff, and it's really important for these power series. The majority of not the majority, a good chunk of the test is going to be on these power series, so it's important that you guys learn this. Okay, I don't usually mean to take 20 minutes on one question, but I try to explain that one in detail. Does that help with your question, Nicholas? Awesome. Does anybody else have any other homework questions that you want to look at? Anything from chapter 10? Excuse me. Chapter 10 questions? Anybody else? Homework stuff? Okay, cool. We still got some time. Oh, sorry, I can't stop coughing. We still got a little bit of time here. So what I want to do is let's just open up the chapter 10 practice test and just do maybe one or two of these together, just so I don't feel like we didn't do anything today. So let's just do maybe the first 3 or 4 of these for practice, at least up to section 3 or 4 stuff, just so we can make sure we're all on the same page. So this first one here, determine whether the geometric series converges or diverges. If it does converge, what is its sum? So that's very common for geometric series, is to ask what is the sum. Like I said before, the only time they're going to actually ask you to find the sum is when it's a geometric series. Otherwise, they're not going to bother asking. So for this one, just to copy it down, we have the sum as n goes from 0 to infinity, -1 to the n, 7 over 3 to the n. Great. For geometric series, there are 2 different ways to write out the series, and it all begins, or it all depends on where the index value begins. If you're starting at 0, like is what we have here, then it's just a times r to the n. If it's not starting at 0, if your index is starting at 1, then all you have to do is shift your exponent over a little bit. Then it would be a times r to the n minus 1. We have the first case for this example, so we'll just deal with that. So what we need to do, and there's a couple different ways, but the main way is to rewrite the series that you're given in the form a constant times something to the n power. It's not too hard to do that. So for our example, we're starting at 0 again. The only thing that is a constant in the series that we're given is this 7. So I'm just going to pull that 7 to the front, and that's going to end up being my a value. Anything that's raised to an exponent, you can combine together. So we have this -1 to the n divided by a 3 to the n. Because they are both to the n, I can combine the -1 divided by 3 and then raise that whole thing to the n. Now what we have that the a is 7 and my r is -1/3. This converges since my r as an absolute value is less than 1. And it converges to that same formula from before, the geometric series sum a over 1 minus r. So just plug it in. A is 7 divided by 1 minus -1/3. So that's going to be 7 over 4/3, which I think is 21/4. We'll just go with that. Oh, I think the answers are at the bottom. Yeah, 21/4. Perfect. So are these okay, geometric series? Is there any questions about these at all? Okay, let's try another one. So this next one's a pretty good one. So this next one is asking you to test the convergence using the nth term test. So now we're going from 1 to infinity of the natural log of 7 over n. Okay, so this one's good just because it's kind of hard and it's not obvious. So first things first, let's talk about the nth term test. What the nth term test says is this. If your sequence goes to 0, the test is inconclusive. If your sequence goes to anything but 0, then the series diverges. All right, so that's all you need to know about the nth term test. If you look at the inside of the series, just the sequence part, the natural log 7 over n, if that goes to 0 as a sequence, then the test is inconclusive and you have to try something else. Or just state that it's inconclusive, like this. Here, state the test is inconclusive. Otherwise, if you find that the sequence goes to anything else except for 0, then the series diverges. The hard part, though, is to figure out what the natural log 7 over n goes to as a sequence. In other words, we're trying to find the limit as n goes to infinity of the natural log 7 over n. All right, that's not obvious what that limit is going to be. So let's talk about some different techniques of how to find that. L'Hopital's rule is not really going to work here because you don't have a ratio or a fraction with a 0 or infinity on top and bottom. I think the best thing to do for this example would be to graph it and look at what the graph of natural log 7 over n goes to as n goes to infinity. So I'm going to go in Desmos. Of course, you could just do this in your graphing calculator. So what we want to know is what does the natural log 7 over x approach as the x goes to infinity. So if you notice here, if I zoom out, it looks like it's getting pretty close to 0, but it's below it, and it's below it forever. What this is telling me, right, is that this sequence doesn't actually approach 0. It approaches something different. And because it approaches something different, that tells me that the series diverges. Since this does not approach 0, then the series diverges. Is that one okay? Does that make sense? We'll go with yeah. I have a feeling that this is going to be how it's like teaching in the classroom next semester. Usually when I teach and I go over something and then I ask, is everybody okay? Are there any questions? I just get a lot of dead eyes looking at me, but at least I could tell a little bit by facial features if they're understanding it, if they're bored, or if they don't understand it. But I imagine when everybody's wearing masks, it's going to be very difficult to see if everybody's understanding it or if I'm just getting this husk of a person looking back at me. Okay, great. We'll just assume that everybody totally knows what I'm talking about and we all know how to do the nth term test. Yeah? Good? Questions? I think that was it for section 3. Was the integral test section 3? I think it was. All you do is the integral for this one. So just try to do the integral. If the integral converges, great, then this converges. If the integral diverges, then great, this diverges. You just have to be careful a little bit with these because you have to make sure that it satisfies all of those prerequisites. It has to be a continuous function. It has to be decreasing, and they always have to be positive values. Like the previous one would not have worked because we ended up with negative values as the n got bigger and bigger. Not that we'd be able to take the integral of that anyway. Next week, or maybe on Thursday, once you guys get a little bit further into Chapter 10, which I know most of you have at least started working on the middle half of Chapter 10, but I know some of you haven't quite got a chance to look at it yet. We'll probably look through a good majority of these on Thursday, and I'll remember to record that as well. But let's do a last call. Is there any other questions from the homeworks? Okay, great. Keep working on the homeworks. Start looking over the Chapter 10 practice stuff. I'm going to create the Chapter 10 test and try to have that up by the end of the week. It's still not going to be due for another week and a half, so don't start stressing out about that yet. But keep an eye out for it here over the next couple of days. And it'll be the same rules for this one as normal. Just take it on your own time at home. You can use any notes and stuff that you have in front of you. And then if you can, upload the Chapter 10 scratch paper stuff into Moodle, and I'll do some partial credit for the test. Let's get out of here, though. It's late. I'm going to go eat some dinner. Thanks for coming. Hope you guys can make it on Thursday. Bring more homework questions on Thursday. Oh, you have a question. Okay, what you got, Rich? Yeah, a lot of you guys showed up today, too. So many people. Big audience. Few questions. Oh, no, Richard, we can't hear you. It's okay. I don't think I have you muted or anything. Look. No, you're not muted on my end. You're muted on your end. I can unmute people. Sorry, Lauren. It's a good thing you weren't doing anything embarrassing.